Okay, welcome to video number 2. Remember, this is still Unit 2, Expressions and Equations. Our very important concept, Vic, for today is distributive property, and we're going to use a few different models to help us visualize distributive property. One of those is an area model. So this is an example of how to think about distributive property using area. I know that you've experienced finding the area of a rectangle before, so think about how you'd find the area of this rectangle. There's really two rectangles kind of coming together here. So if I'm going to find the area of just this small one over to the side, I would multiply length times width, and that would give me 3 times x. If I'm going to find the area of this rectangle here, you take a look at this. Remember, this is 3, this is also 3. So the area of this rectangle would be 3 times 2, which equals 6. Okay? Notice I found the area of those two rectangles, and look at what this is talking about. Okay? This is the same kind of idea that I have. If I did 3 times x plus 2, that's another way to visualize finding the area of the whole thing. Okay? So let's bring together total area. The total area of this rectangle is 3x plus 6. On the next slide, I'm going to kind of show you how this connects to distributive property. So just keep in mind what this looks like. I started off with 3 parentheses x plus 2, area model, and I ended up with 3x plus 6. Okay, again, here it is. You can think about drawing a rectangle to represent any distributive property problem, but here it is if there was no picture with it. 3 parentheses x plus 2. Distributive property tells me I multiply what's outside to what's inside the parentheses. Notice 3 times x, just like we did in that rectangle, and 3 times 2, and I get 3x plus 6. Here are some examples down here, but guys, here's a common mistake or a confusion that we have with distributive property. So here's the same problem 2 different ways, and I want to talk through it with you 2 different ways to make sure that you understand what's going on. When I distribute this -3, and I do -3 times x, and I think about -3 times 2, students really get confused about what to do with this symbol here. So I'm going to show you 2 different ways to think of it, but both ways I'm going to get the same answer. So -3 times x. Okay, think about it this way if this helps you. Bring down your minus and think about distributing -3 times 2. Well, I know -3 times 2 is a -6. Okay? Now think about simplifying that, okay? So sometimes we see our integers in parentheses to show that it's a negative. Make sure that we see that. So -3x minus a -6. Remember, those are what Ms. Simmons called the ding-dings. Minus a negative is the same thing as adding a positive. So this is the same thing as saying -3x plus 6. Okay, same problem, a different way to visualize it. Some students like to kind of do it a little bit of a different way, and both ways are fine. If I said -3 times x and -3 times -2 or -2, look at what happens. -3 times x is -3x, and -3 times -2 is positive 6. Notice I got the same exact thing. So whether you think of bringing down your minus, then distributing, or distributing with this as a -2 or -2, you're going to get the same answer. Okay, quick practice problem. Let's take a look at this one. Guys, remember that the 5 is what I'm going to distribute into all 3 terms inside the parentheses. So here my arrow is going to all 3 terms. 5 times 6p squared. 5 times negative 11p, or minus 11p. 5 times positive 2, or plus 2. Okay, so I did all three of those separately. Now I'm going to bring them together to get my final answer. 5 times 6p is 30, or excuse me, p squared is 30p squared. 5 times negative 11p is negative 55p. And 5 times 2, positive 2, is a positive 10. So don't let these signs in the middle confuse you. Okay, it's time for you to stop the video and to practice two problems. Once you've finished, play the video and see if you got the right answer. Answer for number 1, negative 5 times x, negative 5x. Negative 5 times negative 3 is a positive 15. If you did minus a negative 15, give you the same thing, right? A positive. All right, next one. Negative 2 times 6p squared, negative 2 times 3p, and negative 2 times 9. Negative 12p squared, negative 6p squared, or negative 6p, excuse me, no squared, and minus 18. Okay? Make sure that you show your work, because otherwise I'll think that you just copied the answer.